So this is the second video for week 4, just to show the multiple choice questions. Given the above information, the parameter of A indicates the parameter of A is our intercept, which is right here. So that is saying that when our x is equal to 0, that's what our y value will be. So when our x is equal to 0, our y will be 15.48. Second one says linear regression was estimated. Given the above information, the parameter estimate of B indicates. So the parameter of estimate of B is this estimate. And if we were to write our equation, we would have y equals 15.48 minus 21.36x. And this is our A, and this is our B with our little hats. And if we look at our answer choices, in order for any of these to work, first our answer is D. In order for there to be an increase in y, our x has to go down. And all they are saying is plugging in a 10 for x. And since it's a decrease, it'll be a negative 10 times a negative 21.36. We'll add 213.6 to our A hat estimate of 15.48. Next one says, what is the critical value of t at the 1% level of significance? We have 18 observations, so our degrees of freedom is going to be 18 minus 2, because we're estimating 2 parameters, which is 16. So we look at our t-table, and we see that our degrees of freedom is 16 here at the 1% level on top. Gives us 2.921, which is D. Next one says, given the above information, which of the following is correct at the 1% level of significance? We just said that our t value that we're comparing to is 2.921, which means that this in green is statistically significant because 3.04 is greater than that. However, our B hat is not significant because 2.66 is less than 2.921, even after we take our absolute value. So we get C. A hat is statistically significant, but B is not. Next one says linear regression, same thing. Given the above information, the value of the R squared is up here. This is telling you the percentage of the variation that's explained. So you're just moving over your decimal point, and we get 30.66% of the variation in Y is explained. Given the above information, the exact level of statistical significance of B hat is. That means we're looking at our p-value for our p hat, so we're looking here. And this is the number that we actually care about. So 0.0171. Same as the previous question, just move your decimal point over. We get 1.71. Given the above information, if x equals 20, what is the predicted value? So, sorry about that. We're going to have our equation, which is y equals 15.48 15.48 minus 21.36 times x. So y equals 15.48 minus 21.36 times 20, which gives us negative 411.72, or D. Next one says a firm experiencing is experiencing theft problems, and this is the equation that it gives us. So we have T equals A plus BG plus CU. And I went ahead and already calculated our T-table statistic just so we could speed it up a little bit. So first answer choice, we're trying to see what's correct at the 1% level of significance. And we know this is our T-table value. So the regression equation as a whole is statistically significant because the p-value of f is smaller than 0.01. That's true. You don't even have to actually look up the f-table if you don't want to. The estimates of the parameters a, b, and c are all statistically significant because the absolute values of their t-ratios all exceed 2.797, and that is also true. The estimates of the parameters are all statistically significant because the p-values are all where we would like them to be for statistical significance at the 1% level, so that is also true. They are all smaller than 0.01. The critical value of t is 2.797. That is also true. You can look at the table. So our answer choice is E, all of the above. And then I went ahead and included the table just so you could see it. If you need to see it, it's also in the posted slides. Question 12 says, based off the information above, a 1% increase in the level of unemployment in the country results in an increases in loss of theft due of blank more losses per week. So we're going to have our equation. Sorry guys. Is T plus A plus BG times CU. So T is 5,150.43 minus 480.92 times G plus 211.0 times U. And this is our unemployment. So for each 1% increase in that, it's going to go up 211. So our answer is B, $211. Question 13 says, suppose you're testing the statistical significance at the 5% level from the regression equation y equals A plus BR plus CS plus DW, which is estimated using a time series sample containing monthly observations over a 30-month time period. The critical value of the appropriate t-test is, so we need our degrees of freedom, so it's going to be 30 months because there's 30 observations, minus 4 because we're estimating 4 parameters, which is going to give us 26 degrees of freedom at the 5% level. So we get that our critical value is 2.056. Next one says, refer to the following computer output from estimating the parameters of a nonlinear model. if you want to change it into a linear model, this is going all the way back to logarithm rules, which either you remember and you like or you really don't like. If you don't like them, just if it's by itself, it just goes after the natural log. If it's an exponent, it goes in front of the natural log. So we end up with d, which is the natural log of y equals the natural log of a plus b times the natural log of r, plus c times the natural log of s plus d times the natural log of t. Next one is based off of the info above, which of the parameter estimates are statistically significant at the 90% confidence level. So we have 32 observations. We're estimating 4 parameters, so there's 28 degrees of freedom. These are our t-ratios, so we're comparing them to this number. All of those numbers that are circled in brown are greater than our 1.7, so all of our parameter estimates are statistically significant. And this is where it's coming from, our degrees of freedom and our confidence level. Based on the information above, if R decreases by 10%, everything else held constant, it's going to be 4.66 times 10, which is going to give us 46.6%, which gives us don't make the same mistake I just did because I'm going too quickly. It says decreases by 10%, so this is a negative 10, and our results will decrease by 46.6%. Next one, if S increases by 8%, so negative 0.44 times 8 will give us negative 3.52%. So our answer is A. The quadratic equation y equals a plus bx plus cx squared can be estimated using a linear regression by estimating, and it gives us a lot of choices, but none of them work. Mainly because none of their recommendations actually do anything. If you were to multiply them all out, it still won't work. But to save time, if you have questions on that, let me know. 19, a manager wishes to estimate an average cost function. Which of the parameter estimates are statistically significant at the 1% significance level? So we have 28 observations. We have 3 parameters that we're estimating, so there's 25 degrees of freedom, which is going to give us a 2.787 critical t-value. And if we look at our t-ratio, we see that our intercept is greater than that. Q is not, even after we take the absolute value, and Z is. So all parameter estimates except B hat are statistically significant. This is where I got the 2.787. And then the last one is just plugging in some math. So we have C equals 200 minus 12Q plus 0.5 q squared. We're going to plug in 40 for our q. So C equals 200 minus 12 times 40 plus 0.5 times 40 squared. C equals 200 minus 480 plus 0.5 times 1600. So C equals 200 minus 480 plus 800, which equals 520, or E. So that's it. If you have questions, please let me know.